If you're an executive at a municipal water authority or a site manager at an industrial facility, you're probably aware of the changing regulatory environment for PFAS. John Peichel, Global Market Development Lead, has co-authored a new white paper on this very subject. He's here today to talk about what you need to know when you're implementing a PFAS mitigation plan. John, let's start right at the top. How do I know if I need to address PFAS in my water or wastewater?
Well, PFAS is definitely a complex and ever evolving issue, both in understanding it and the regulatory landscape. So, most likely, if you're working at a facility that has PFAS in its feed water or wastewater, you're already very much aware of what the guidelines and/or regulatory requirements are. What you need to focus on is how can some of those guidelines today become regulatory requirements in the future, and how do you plan for treating that PFAS going forward?
Okay, so where do we start? What is the first step in putting together a plan?
Well, PFAS treatment is very complex, partly because of the wide variety of PFAS constituents that are out there. And when a customer or a client looks at developing a treatment solution, we ask them to look at it holistically, not just the technical, but also the economical aspects of treatment. How will that system be operated? How will the PFAS be destroyed or disposed of? All of these factors need to come into coming up with a treatment solution. And then we like to take various steps towards that treatment.
So, what are some of the parameters you consider?
Well, there's a number of factors that we'll take in developing a treatment solution, starting with the specific PFAS contaminants to be treated. We want to characterize those PFAS types along with competing contaminants so we have an accurate idea of the treatment challenge in front of us. In testing for competing contaminants, we realize industrial wastewater can be incredibly complex. High levels of suspended solids, dissolved salts, all of which can adversely affect the treatment technology we use to remove PFAS, and so we have to factor that into our solution. And every project has to consider life cycle cost, the cost of the equipment, the cost of operation, and in PFAS treatment, particularly the cost of disposing or destroying of the captured PFAS. And so each location will be unique, and many locations come with built-in site constraints. They either have space limitations or the logistically where to haul off or dispose of media or PFAS that's ready for destruction or disposal. And then no solution is perfect. All the technologies have limitations, and we have to factor those limitations into account when you devise the treatment flow sheet. And finally, we look at the aspect of future proofing. How can the treatment selections we make today serve us the best as changing water supplies or changing regulations require us to adapt the treatment solution to meet those new requirements? That's called future proofing your solution. And we like to try to take that into account in initial system design.
Is there a way to test different options to make sure the site has the right flow sheet?
Yes, we can think of it kind of as three specific steps. The first step being one of water sampling and testing to do analytical characterization of the PFAS and those competing contaminants to make sure we're taking all of the factors into account when we select technologies for treatment. The next step will be to take a sample and take it to the lab for actual running on a small scale in the lab in a very controlled conditions. We often employ rapid small scale column testing where we can put different types of media into a column, run that real world sample through, and really optimize the conditions for optimal PFAS collection and removal. Then the third step is to take those learnings into the field and perform a pilot test. In a pilot test, we deploy equipment to run for several weeks or months and really gather the data we need to optimize the full-scale treatment solution. We often deploy our mobile equipment in trailers so we can test multiple treatment technologies on site very quickly.
John, thank you so much for joining us today. There's obviously a lot to consider here, and it sounds like having a partner to work alongside you through those considerations is a huge advantage.
I agree, and thank you very much for having me.
For more information about treating PFAS, visit watertechnologies.com/PFAS.